So we want to show that this function on the interval 0 to 8 pi is a probability density function. One thing that you should definitely check is that whether this function is positive on this. And sine of x itself has the graph like this from 0 to pi, so it's positive. And what happens is that if you divide this by a, the entire interval expands to 0 to 8 pi, so it still has this shape of the graph, so it is positive. Now, for a probability density function to be a probability density function, you need it to be positive, and also the area should be 1. So that's what this first question is about. For the area of this to be 1, b has to satisfy certain conditions. So let's see what that is. Integral of b sine x over a dx from 0 to 8 pi. And sine integrates to cosine with a minus. And then anytime you have a coefficient like this, the reciprocal comes in front. So 1 over a is just a. So you have ab, negative ab cosine x over a, and you're plugging in a pi and then 0. When you plug in a pi, and this a pi is plugged in, a pi divided by a is just cosine pi. Let's factor the ab out, negative ab out. And then when 0 is plugged in, it's cosine 0. And hopefully you remember that cosine graph goes like this. This is the cosine graph. Actually, this will be from 0 to 2 pi. So if you have cosine from 0 to pi, it has the value of 1 at 0 and negative 1 at pi. So that gives you negative ab of negative 1 minus 1, which gives you 2ab. Now, I need this to be 1, and that means that b must equals to 1 over 2a. So that's the answer to part A. Now, question B says, find the expectation value of x. Expectation value by definition is you have to, e of x is 0 to a pi. Remember that b is 1 over 2a. So you multiply x by the PDF, and PDF for us is 1 over 2a times sine x over a. Okay, let's move the 1 over 2a in front because that's just a constant. So you're just integrating x times sine x over a. And when it comes to doing integration by parts, especially when you have a polynomial multiplied by sine or cosine or exponential, in those three cases it's best to do the integration by parts using the tabular integration, which is you must have the sine part, derivative part, and the integral part in this order. And the derivative part chooses the polynomial that is being multiplied. You keep differentiating until it hits 0. And then the other part is the one that you integrate. Sine x over a is the one that you integrate. If you integrate that, that gives you negative a sine x over a. Integrating, anytime you integrate, cosine. Anytime you integrate, the reciprocal of this number comes in front. So if you integrate again, it will be negative a squared sine x over a. Now you have plus, minus, plus. This column just alternates signs, and then you do this in order to get the result of the integration by parts. Okay, so what is this saying? We pull the 1 over 2a out, according to this, the integral is negative x times a cosine x over a. Okay, and then this is the next one. It's negative 1 times negative 1, so it's plus a squared sine x over a, and you plug in a pi and then 0. And then when a pi and 0 goes into sine, both of the values are 0, because again sine is 0 at 0 and pi. That's the graph of sine. So that's not going to produce anything. When this is plugged in here, we just said that cosine pi is negative 1, so it's going to give us negative xa times negative 1 minus, when you plug in 0, it will be plus 1, but minus will be plus. Oh, this x should also be, oh, right. A pi also goes into x, so it's a pi times a times negative 1. That's what you get when a pi is plugged into both. When 0 is plugged in, this 0, having 0 over here makes 0 times something, which is always 0. So this is what you get. A cancels, and then negative is positive, so you get a pi divided by 2. Now, notice that this answer is somewhat obvious because, as I said, our probability distribution function is 0 to a pi, and it is symmetric over this midpoint a pi over 2. So if you're looking for the expectation value, which is just another way of saying average or weighted average, it will give you the mid one. Okay? If the probability distribution function doesn't look symmetric, if it was like something like this, then you would know that the average would be more tilted to the right. But in our case, it's perfectly symmetric, so a pi over 2 is the answer. That's another way to verify that you've done the calculation correctly. Okay, now part C is asking us to find the variance, and to find the variance you must make use of the formula e of x squared minus e of x entire thing squared. This is the formula for the variance, and then since we already know e of x as a pi over 2, this part is something that we already know. So that means we first have to calculate e of x squared. Let's see how that's done. So this calculation is exactly like the one that we just did, except that now instead of x, we use e of x squared. So this is x squared, and then 1 over 2a sine x over a dx. You pull this out and just do another one of these tabular integration. Let's do that. The polynomial now is x squared, so we have x squared, 2x, 2, 0. Keep differentiating until the whole polynomial hits 0. And then you have sine of x over a, negative a cosine x over a, and then minus a squared sine x over a, and now plus a cubed cosine x over a, and now you, oh, there should be plus minus here. Okay, so you do this and obtain the result of the integration by parts. So this thing now becomes, let's see, 1 over 2a is the thing that I pulled outside first, and then you have x squared times negative a times cosine x over a. The next one is plus, minus times minus is plus, so it's plus 2a squared x sine x over a, and then 2 times this, so it's plus 2a cubed cosine x over a, and you have a pi and then 0. Okay, again, when a pi and 0 are plugged into sine, they go away, so we don't get anything from here. When a pi is plugged into here, you get -1, a pi squared, and there's a minus, so you're going to get a pi squared minus a times -1 when a pi is plugged in. When 0 is plugged in here, 0 times anything is 0, so that doesn't give us anything. When a pi is plugged in here, that gives you -1, so it'd be 2a cubed times -1. And when you plug in 0, cosine of 0 is 1, so you subtract 2a cubed times 1. Notice that it's, you plug this in minus you plug this in. That's why this, you have to subtract those two values. That's why you have this minus. Okay, so now let's carry on and see what we get. This is going to be 1 over 2a, -a cubed pi squared, and then you have 2a cubed minus, so it'll be minus 4a cubed. Oh, this should be minus, so this would be plus. Okay. All right, so one thing that you should check is that since you're taking the average of the x squared value, that value can never be negative. E of x, it could be negative, but e of x squared can never be negative. So, see, pi squared is about 9. 9 minus 4 is bigger, about 5. So, indeed, this is bigger than 0. That's something that you should always check. That was why I was able to see that I made an error here. So, always try to have a bunch of checks of what your calculation gave you. Okay. So a cancels, and you get 1/2 of a squared pi squared minus 4a squared. Okay. Now finally, you can subtract ex squared, so you're going to get v of x equal to 1/2 a squared pi squared minus 4a squared minus, it was a pi over 2 squared. This was our e of x, right? So that is going to give you, this will be 1/2 a squared pi squared, this will be 1/4 a squared pi squared, so that's going to be 1/4 a squared pi squared, and then minus 2a squared. So that's your, that is going to be your variance. Another thing is variance is also always positive, so you should check again whether it's positive. So this is 3 squared, which is about 9. So this is about 9. 9 over 4 is about 2.25 minus 2. So that's still positive, right? Yeah. So this is indeed positive. Okay, finally, we have probability of 0x a pi over 3. To get the probability from the PDF is just you just integrate that PDF function, which is in our case is 1 over 2a sine x over a dx on the given interval 0 to a pi over 3. This one is going to be 1/2 cosine x over a, and you have to plug in a pi over 3 and then 0. Okay, so the integral of this is negative. I forgot the negative. So if you do this, then you get negative 1/2 cosine, AA cancels when you plug this in, you get cosine pi over 3 minus cosine 0. Cosine 0 is 1, cosine pi over 3 is 1/2, so it's negative 1/2 times 1/2 minus 1, which is now positive 1/2, positive 1/4. So that's the correct answer.